Thank you, Clara. Thank you. And welcome, everybody. Thanks so much for attending this evening. It's very cheering for me to see that there's so much interest in this. It's always great to know that. So, yeah, we've got quite a lot to get through, as is my kind of style of presentation, but at least it's being recorded. So if I'm going quite fast, you can always look back at the recording later on. So what we're going to look at this evening is the impact of dyslexia on maths, and also what dyscalculia is. Now, quite often these two things co-occur. So it's, as you know, it's quite unusual often for children just to be dyslexic and nothing else. Often it co-occurs with dyspraxia or dyscalculia. So we're going to look at the interplay of those things as well. And I also want to touch on maths anxiety because it's such a big issue, particularly after the pandemic. Lots of children now are struggling with maths anxiety, and this goes hand in hand, really, whether your dyslexia is affecting your maths or your dyscalculia is affecting your maths. Yeah, you quite like to have maths anxiety. So I'm going to give you some tips and strategies for how to alleviate that anxiety, as well as strategies to cope with the difficulties that dyslexia and dyscalculia may present when you're trying to do maths. So we know in terms of dyslexia that these are the issues for people with dyslexia: phonological awareness, processing speed, memory, and organization. And there has been some research into not only the co-occurrence of dyslexia and dyscalculia, but also that there's some kind of phonological awareness link with dyscalculia, and we're not quite sure what's going on there, but there is in dyscalculia a magnitude processing difficulty. And on the face of it, we think of it as children not being able to say which is the larger number. So would they look at 6 and they look at 10 and they can't tell you which is the bigger number because they haven't associated the numerical magnitude to those numerical symbols. But we also know that this magnitude processing difficulty actually extends beyond just the magnitude of numbers. It can be the passage of time, it can be intensity of tone, and I think this might be where the phonological awareness link is coming in, and also even magnitudes of lengths of pieces of rope or string or anything like that. So it's an interesting field. We need to do a lot more research into dyscalculia. It's certainly 20-30 years behind the research that's done in dyslexia, but it's very interesting, this co-occurrence and the interplay between the two. So all of these identifiers, I suppose, of dyslexia potentially are going to have an impact on mathematics. So people with dyslexia, they may have difficulty with sequencing, and that can be really problematic in mathematics.
I'm here, Eddie.
Gillian, your iPhone is not muted. I've just seen your name pop up on the screen. So you've got sequencing difficulties, you've got processing speed. And I think if children are looking at a mathematical problem, and maybe it's a multi-step problem, they may have difficulty in keeping the right sequence of the steps of that problem, the algorithm that they need to carry out. But also, if their processing speed is quite poor, then they're going to lose the thread of what they were trying to do with the calculation as they work through the calculation, because it's taking them a long time to think about the different steps. Poor short-term memory can be an issue as well. And particularly with working memory, long-term memory and working memory. Now, I've put here about long-term memory for retaining number facts and procedures. One of the issues, I think, with dyscalculic children is that they haven't associated the numerical magnitude to the numerical symbol. So when you're asking them to remember number bonds to 10, it's incredibly difficult for them, because if you say to somebody with dyscalculia 3 + 7 = 10, and they haven't got an image in their head of what 3 is all about and what 7 is all about, they can't visualize how 3 and 7 = 10. It's just a word 3 that they have to remember goes with the word 7, and then the word 10 happens at the end. So again, for people with dyslexia and dyscalculia, it's a huge burden on their memory because they haven't got the meaning that goes with these number facts. And I often equate it to particularly learning the times tables. If you're saying 2 times 3 equals 6, you might as well be saying A times Z equals P. Just learn it. That's a fact. And that has no meaning for us. If I said to you, you've got to remember that A times Z equals P, you'd be looking at me as though I was crazy, because there's no meaning to it. But that's what it's like for people with dyscalculia. So memory difficulties with dyslexia are going to have a huge impact on mathematical development, because it relies a lot on you having recall of these facts, recall of procedures, but also working memory as well. So when we're working with mental maths and we're trying to work out calculations in our head, we're relying on our working memory. So we're storing information in our memory, we're manipulating it, we're doing something with it, and then we're producing the answer. And if your working memory is compromised, that's going to make working with maths very troublesome for you. And also word problems. Now that's quite a big issue for people with dyslexia. Sometimes it's not that they can't do the maths, it's that they don't understand the maths that they need to do from the word problem. And I'm going to show you some strategies this evening that are really, really helpful, I found in my experience, helping children to decipher these word problems and to make sense of them. So we're going to spend a bit of time looking at some of the strategies to support children with word problems. And other difficulties that they may experience, things like substituting names that begin with the same letter. So integer and integral, completely different things mathematically, diameter and diagram. So they start with the same letters, but they've actually got a completely different mathematical meaning. And then we also have specialized mathematical vocabulary like numerator and denominator. And these are things that aren't common in our daily speech. We don't go around saying numerator and denominator unless we're in a maths lesson. So that can be quite tricky as well for children to remember this specialized vocabulary. And as is the case for dyslexia, whatever subject you're working in, copying is an issue. So copying errors can make obviously a big difference in mathematics. If you've copied the numbers wrong, then that's going to make the sum wrong. Losing your place, if you've got a whole sheet of calculations that you need to do, it's very difficult sometimes to go back to the question that you were on and make sure that you're picking up the right information. And then you may have visual perception and reversals. So 3 and capital E look the same, 2 and 5 can be confused, and also plus and times is just a different orientation to make a plus sign into a multiplication sign, and obviously that has huge implications for the calculation that you're trying to do. So if we're looking for strategies to help dyslexic children with maths, multisensory teaching is a given, it's the way to go. So make sure that everything that you do is channeling the visual, the auditory, the kinesthetic. Try and get children to verbalize what they're doing in mathematics, so they're actually talking about the strategies that they're using. And make sure that we use the CPA progression. So that is the concrete, pictorial, abstract progression. And back in the 1960s, Jerome Bruner was the main kind of pioneer of this. And he said, if we want to learn anything, really, we need to experience it in a concrete way first, a physical way first. And then we need to have a pictorial representation of that concrete representation before we get to the abstract. And I think this is a big problem for lots of children, regardless of their neurodiversities. We tend to kind of rush to the abstract in maths too quickly, and we don't spend enough time with the manipulatives, with the equipment, with having diagrams and pictorial representations. And so the children are kind of left working at an abstract level without that depth of understanding that comes from using the concrete and the pictorial representations. And we know with dyslexic children, often their visualization is very good. They're thinking in pictures. They want to see things. They want to have diagrams. And that's one of the best ways that we can help them in maths, is to support and develop their visualization skills, because often that's a real strength for dyslexic children. So the more that we can enhance that, the better. Another thing we can do is have memory cards. Now, memory cards are a little bit like the reading packs and spelling packs that a lot of you will be familiar with if your children are dyslexic and have had dyslexic interventions. They will have reading packs and spelling packs. And you can do exactly the same thing with mathematics. So you can get little credit card sized bits of card and then put on the card the things that the children struggle to remember. So it may be a times table fact. It may be a definition of a mathematical term. It could be anything really that they need to practice. And the idea with these memory cards is that you build up a little set of cards that the children practice on a daily basis, at least 5 times a week if you can. And the children just go through the cards every day. And it's just this idea of overlearning. So little and often overlearning that we know is absolutely essential for our dyslexic children. You can do exactly the same with maths. So the little and often approach is a really effective way of supporting these learners. Another thing we can do is use aperture cards. And what I mean by this, if your child is working from a textbook or a worksheet that they've got from school, there's going to be lots and lots and lots of questions on that page. And it's very difficult for the children, as I say, to find their place. If you cut a little window out of a piece of card and put that over the questions, then they're just focusing on one question at a time. So just having that little window, a bit like a reading ruler, really, you could use reading rulers as well, just so that the children are focused on one question at a time and they're not mixing up the numbers from one question with the numbers from another question. The other thing as well in maths is that sometimes we work left to right and sometimes we work right to left. So we can highlight, we can use arrows, we can colour, code things to help the children know that in this particular calculation we're going left to right, but in this one we're going right to left. So that's a really useful thing to do as well. And while we're talking about direction, if you've got children who are reversing their numbers, so they're writing their 3s backwards or back to front or something like that, what I tend to do is I tend to have different colours. I have 2 colours for the numbers. So the ones that go left to right will be in one colour, and the ones that go right to left when you're writing them will be in a different colour. And that can just help the children with their number reversals. And of course, as we always say with dyslexic children, just try to limit copying from the board as much as you possibly can, because it's such a burden on their working memory, and they're not going to have any brain space left to think about the maths because they're so focused on the copying. So try and avoid that as much as you possibly can. So I said before that dyslexia and dyscalculia, they co-occur very commonly, much more than we would statistically expect from the individual prevalence of each of those neurodiversities. So what is dyscalculia? And it's something, more and more people are becoming aware of dyscalculia and wanting to know what it's all about. So back in 2019, the BDA, the British Dyslexia Association Dyscalculia Committee, of which I'm vice chair, we came up with a definition, and we had lots of people around the table. It was really difficult to kind of come up with a definition, and I think our first attempt went to 2 sides of A4, which just wasn't really practical. But we kind of came up with something which we're hoping is going to be a working definition and would be widely adopted. So it's a specific difficulty, yes, it's persistent. You're never going to be cured of dyscalculia. It's a lifelong condition. And as I've said, it affects the retrieval of number facts and procedures, not just because of any memory issues, but because of the fact that they haven't attached the numerical magnitude to those numerical symbols. Very diverse in character, so it can present in lots of different ways, and it occurs across all ages, all abilities, not gender specific or anything like that. But I think the key thing to think here is that it's an unexpected and unexplained difficulty. So often with dyscalculic learners, everything else is fine. It's just that they are really struggling with maths, and it seems to be for no particular reason. And it cannot be explained away by external factors. So things like maybe missing a lot of school, or perhaps having some poor teaching or that kind of thing. So those external factors can have an impact on maths, but dyscalculia cannot be explained by those external factors. It's an unexpected difficulty. And it's thought of as a continuum rather than a distinct category. Now, I have a little issue with this. I think dyscalculia is quite distinct because it's such a profound difficulty. I think it's quite easy in a way to identify children with dyscalculia because it is such a profound difficulty. They really don't have a grasp of our number system and how numbers relate to each other. And it's all to do with this magnitude processing difficulty. So they have difficulty with symbolic and non-symbolic magnitude, number sense and subitizing. We're going to look at subitizing in a moment. Number sense is a tricky one. And if we had time and we were all in a room together, I'd say to you, well, what do you think number sense is? And you'll get all sorts of different ideas, people talking about place value and all of that. But for me, I think number sense is really understanding our number system, where a number lives in our world of number, in our number system, how numbers relate to each other, and being flexible with number, understanding what we can and can't do with number. So if you have good number sense, you're going to look for connections, you're going to look for the easier way to do something. So for example, if you were adding 29 and 30 and 31, you might think of that as 3 30s, because you know that 31 is one more than 30, 29 is one less than 30. So we can just think of it as 3 30s and get the answer 90. If you don't have that number sense, if you haven't clocked that 31 is one more and 29 is one less, you're going to do a column addition. So having good number sense opens up an easier version of maths for you. So our dyscalculic children are doubly disadvantaged, if you like, because they're already struggling with maths, but they're doing a much harder version of it because they're always just going back to the procedure rather than the kind of more efficient, quicker route to the answer. So those are the three things really that you need to be looking for with dyscalculia. Subitizing, we're going to have a look at in a moment, number sense, and this symbolic and non-symbolic magnitude. And as I said at the beginning, it often co-occurs with other learning difficulties such as dyslexia, dyspraxia, ADHD, that kind of thing. So one of the main indicators of dyscalculia is this inability to subitize. Now, subitizing is our ability to immediately see how many items there are in a set without actually counting them. It's an instantaneous recognition of quantity. And this is why I think dyscalculia is quite easy sometimes to identify, because if you've got a group of children, a class of children, where everybody can subitize except for one child, you're going to think that's a red flag. There's something going on here. This child doesn't have this instantaneous recognition of quantity. And I'll give you some examples of that in a couple of slides' time. Poor number sense, as I mentioned before. So this not being flexible with number, not understanding what you can and can't do with number, not understanding the effect of the 4 operations, all of those things would indicate poor number sense. And then we've got this magnitude processing difficulty that I've already described. An inability to generalize. Now, What this means is that if you can generalize, you're using something that you know and you're making a connection to something else. So if I know that 3 + 4 = 7, I can generalize that fact and think, well, if 3 and 4 is 7, 30 and 40 must be 70, 3 million and 4 million must be 7 million, or even, 700 take away 400 = 300. So I can use that basic fact and then generalize and make connections and make links to everything else. But people with dyscalculia find this really difficult. They don't make those connections, they don't generalize. And so for them, every single calculation they see, every number bond, every fact, lives in isolation and is completely unconnected to anything else. And so the impact of that is they have a huge burden on their memory because they're not making those connections. 3 and 4 is 7 is something they have to learn. 30 and 40 is 70 is something completely different that they have to learn. So you can imagine that the kind of impact of that on their memory and getting information into their long-term memory. And the other difficulty that dyscalculic learners have is this inability to estimate whether an answer is reasonable or not. And many children don't like to estimate. It's another step that they have to do. But in a way, it's really important that we do encourage children to estimate, particularly dyslexic children, dyscalculic children, because it's a safety net for them. So if they can estimate, if they have some idea of what the answer is going to look like, that's going to alert them if they get a vastly different answer. So say if you were adding 23 and 54, and you got the answer 2,354, if you've estimated first, you're going to think, no, it can't possibly be that. I've got two-digit numbers. I'm not going to end up with a 4-digit number. So it's really, as I say, acts as this kind of safety net for children, really worth spending time helping children to round numbers and to estimate to an appropriate degree of accuracy. The other thing you might notice as well is that children with dyscalculia will tend to stick to immature strategies. They'll find something that's worked once for them and they will apply it religiously ever after. So if when they were working in reception, for example, and they were looking at 2 + 3 and their strategy was to count everything, that's a perfectly fine strategy for 2 + 3 at that stage of your life. But when you are looking at 262 + 378, and you start drawing the dots because you're going to count everything, that's not an appropriate strategy. So one thing to look out for is children who are kind of not progressing from these immature strategies, counting all instead of counting on, or counting all instead of using part, whole models. Inability to notice patterns as well is a big issue for people with dyscalculia. And the more that we can notice patterns, the easier that life becomes in maths, because we can predict future events. So we know if we're looking at the 5 times table, for example, 5, 10, 15, 20, 25, 30, we know the next number is 35. But a dyscalculic person, you can go through that and they'll get to 30, and then you'll say, what comes next? And it'll be 31, 32, 33, 34, 35. They'll have to count on with their fingers. So again, putting huge burden on their memory, and all of these things are going to impact for dyslexic children as well, who may have compromised short-term working and long-term memory. It's a huge burden on their memory. And then you've got other indicators that in and of themselves really aren't necessarily indicators of dyscalculia, but they may be co-occurring difficulties that are present. So slow processing speed, difficulty sequencing, particularly for our dyslexic learners, difficulty with language, mathematical language, and poor memory for facts and procedures. And as I said before, difficulties with word problems and multi-step calculations. So subitizing. Now, Subitizing, as I said, is our ability to see how many items there are in a set without actually counting them. And the birds here are all bunched up. It's quite difficult, isn't it, to see, is there 5, is there 6, is there, because they're all kind of squished together. But I'm going to show you a slide now, and hopefully you'll instantly say how many dots there are. So here's the slide, and I'm hoping that you could look at that and say immediately, without a moment's hesitation, that there are 5 dots there. And that's what we mean by subitizing. It comes from the Latin subito, which means immediately. So it's an absolute instant automatic response, 5 straight away without thinking about it. Now, if I show you the next slide, that's not so good. There's too many dots there for us to absolutely instantly say with 100% certainty how many there are. You might think there's 10, 11, 9, 12, but you're not entirely sure, in the same way that you were with this one. And typically, where you've got dots that are randomly arranged like this, a typical person can subitize 5, maybe 6. Anything more than that, and you're quite likely to be subitizing 2 individual subsets and adding them together to get the quantity. So it's not true subitizing. And for somebody with dyscalculia, they find this quite tricky. They may not be able to do that. They probably won't be able to do that. We wouldn't expect them to be able to do this, but they might not be able to subitize even 2 items. So in that respect, it's not a diagnosis of dyscalculia by any means, but it's certainly something that's always in the dyscalculia screeners. It's one of the first things I would look at, and it raises a red flag that maybe there's something going on here that's a neurodiversity, because this isn't a typical way that we would expect the children to present. So in terms of word problems, one of the most effective solutions, if you like, that I've ever come across is the bar model. And the bar model, very, very popular in Singapore, and now actually quite commonly used throughout the UK, throughout the world, because it's so successful, it's so effective. And really all it is instead of using X and Y, it uses rectangles. So it's just representing number with rectangles, and it's a really strong visualization of the mathematical problem that the children are looking at. So here you can see an example of a bar model, and we've got a rectangle to represent the 7 boys. We've got a rectangle to represent the 21 girls. And the important thing about the bar model here is that we're labeling the rectangles, but we're also labeling the question mark, if you like. And the question mark is saying, this is what we want to find out. And it's the question mark that's telling the children, showing the children what operation they need to do. So here we're looking for the difference between the boys and girls. So we would be looking at subtracting 7 from 21. If those 2 bars were side by side next to each other, and the question mark bracket was across the whole length of both bars, that would be telling us that we've got 2 parts and we need to add them to find out the whole. How many children are there altogether? So it's a very simple model. There's only really 3 different types of bar model. There's the part whole, which I was just describing, where you've got 2 parts next to each other and looking at the whole, or the comparison, which is what we had here, where we're comparing 2 bars. Or you may have a before and after model, which is where you've got a situation at the beginning, which could be part whole or comparison, something changes, and then you've got a different bar model at the end. So that's really all there is to it. So a part whole model would look something like this. So you may be given the whole and 1 part, and you've got to find the other part, or you may be given both parts and you've got to find the whole, but the model is the same. And Again, here you've got an example, just another example of the comparison model for addition and subtraction. So here it's slightly different because we're given the number of boys, we're given the difference, and now we've got to find out the number of girls. But in all of the scenarios, there's 3 bits of information and you'll be given 2 of them. And that's how that kind of works. So when we're looking at the comparison model, we need to know what the unit part is, and we need to know what the difference is, or we need to know the whole so we can find the difference. So I'm going to give you an example here. And the bar model, when you kind of introduce the bar model to adults, we are bringing our own way of doing maths with us. And we, generally speaking, when you're given a word problem like this, we will focus on the numbers first of all. So, and that's not necessarily what you want to do with the bar model. So here we've got John, who's got 3 more shells than Kim. Altogether, they've got 15 shells, and we want to find out how many shells John has. Now, whenever I do this face-to-face with teachers, parents, invariably what they do is they think of that question and they think 15, I'm going to start with a 15, and they'll draw a bar that's going to be representing that 15. So they'll have a bar on the page that they've drawn, maybe labeling it 15, and then they'll start thinking about the 3 more and how that's going to work. Now, that's not necessarily incorrect. You may well end up with the right answer, but actually with the bar model, what we want to do is start with the thing that we don't know. And that's a little bit counterintuitive. Children pick this up really easily. Adults less so, because they're like, why are we starting with the thing we don't know? I know there's 15, let's start with 15. But actually, if you start with the thing that you don't know, you can start building up the bar model, and it makes the visualization make much more sense. So here, what we're doing is we're going to have something for Kim. So if you're just looking at method 1 here at the top. So we don't know what Kim's got, but we're just going to give her a rectangle. And we know that John has got 3 more than Kim. So John is going to have a rectangle that's exactly the same length as Kim's and 3 more. And we were told that altogether they've got 15. So you can see here now we've got 2 equal units. We don't know what they are, but that's okay. We don't know what the value is, but that's okay. But we do know that this is 3. And we also know that the whole thing is 15. So if we take that 3 away from the 15, we know that these 2 units must be 12. And so each unit must be 6. And then altogether, John will have 9 and Kim will have 6. Now you could do it that your unit was John and Kim has got 3 less. You'd still get the same answer. But I just find it a little bit easier if we work like this, that we're adding something on rather than taking something away. But both of those methods will work. So you can see here, it's a very clear visualization of the problem. And this next problem was really, for me, a kind of game-changing moment, if you like, because when I was teaching back in the day, I would say to my children exactly, what I'm sure a lot of you would do. You'd look at a word problem like this and you'd immediately focus on the numbers. So reading this, Thomas has 4 times as much money as James. Together they have £200. How much money does James have? And the temptation is to focus in on the 4 times and the 200. And that's how I would have taught my children when I was doing word problems. But it's not actually the best way to do it. Because in this particular example, if they're focusing on the 200 and the 4, that's not actually going to help them. They don't need to divide by 4. They don't need to multiply by 4. What they've got to do is divide by 5. So I would come along and say to the children, oh, no, you've got to divide by 5. And they're like, where's the 5? There's no 5 in this question. And at that point, children will often think, I don't get word problems, they're really confusing. And because they haven't got this word problem, they may kind of extrapolate that and think, well, I can't do any of them then. Word problems are not for me. So if we go back to thinking about the bar model and thinking about starting with what we don't know, do we know what James has? No, we don't, but that's okay. Let's give James a rectangle. So we're going to give James a rectangle. And we do know that whatever James has got, Thomas has got 4 of them. So you can see here, I've done the diagram, but there's no numbers. I haven't put any of the numbers in yet because I don't need to. So I'm just starting with giving James something. Thomas has 4 of them. And then you can immediately see why we're dividing by 5. There are 5 equal units here. So effectively, this question is a ratio question, ratio 4:1. There's 5 parts altogether, but we don't even need to use that language. So we don't need to confuse the children, potentially confuse them by using that language. We can just say, James has got something, and whatever he's got, Thomas has got 4 times as much. So 4 of whatever James has got. Then we can put in the numbers. Oh, sorry, the slide's missing. Then you can put in the £200 there. And then you can see that what you need to do is divide the 200 by 5. So it's just a little step in between the word problem and the calculation that they need to do, but it's a very powerful visualization. And it's really helpful for our dyslexic children, because that's the way they like to think. They like to think in pictures. So it's the way to help them to get from the word problem to the calculation that they need to do. So we're just going to have a look at one more, and then I'm going to take you on to a different strategy. So we're going to move away from the bar model. And this one, when you look at this question, this can be quite overwhelming for children because you've got 2 different fractions and you've got money. So they're going to look at this and think, oh my goodness, what's going on? We've got fifths, we've got halves, we've got pounds. It's all really going to be a very troublesome problem. So again, if you're thinking about the bar model, we don't need to worry about putting the fractions on, the numbers on. We're just going to draw the model. So let's have a look and see if we can understand what this question's all about. So Ben has spent 1/5 of his savings on a gift, and half of what's left he spent on a book, and the book's £12. So we want to know how much were his savings. What had he saved up? So we can start off by having a rectangle. So we'll draw a rectangle here that's going to be the whole of his savings. And again, I don't need to put any numbers on it, that's fine. But I do know that he spent 1/5 on the gift. So I can draw a line down here, roughly 1/5 of that bar. Now, once I've got to this stage, I've got a little bit of a problem because I've got a part here that I don't know, and I've got a part here that I don't know. So I've got 2 things that I don't know. So that's not very helpful. If I've only got one thing that I don't know, I can work with it. So the best thing to do now is to split the whole bar into fifths. And now I know that each of these parts are the same value. So here I didn't know that, but here I know, because I've split the whole thing into fifths, that each of these parts are exactly the same. So now I can think about the question, and it said he spent 1/5 on the gift, and then he spent half of the remainder on the book. Well, there's 4 parts left, 4 units, 4 pieces left. So 2 of them must be the book. But we were told that the book was £12. So now we know that 2 units is 12. So each of these parts must be 6. So 1/5 on the gift, those 2 are the book. So each one must be 6. So therefore his savings were 5 times 6, which is 30. So we've made that quite complicated question more accessible through the use of the bar model and the visualization. So if you're not using this in school, or if your children aren't using this, there's lots of stuff online about the bar model. It's quite readily available these days, and I would thoroughly recommend that you have a go at it, because it's really super helpful for word problems. The next thing that I wanted to share with you is this idea of numberless word problems. Now, I only came across this 4 or 5 years ago now, and I thought, what a genius idea. Very, very simple, and really it does what it says on the tin. You just take the numbers out of a problem. So wherever you've got numbers in a word problem, you just take them out. So I'm going to show you a really simple example just to illustrate the methodology of it. It comes into its own a lot more when you've got bigger numbers and more complicated numbers, but just for the point of demonstrating it, I've just got this quite simple example. So the question is that Sita has 50 raisins and she gives 23 to Ben, and she gives 15 to Amy. How many raisins does she have left? Now, often with these problems, children are thinking, is this an addition? Is it a subtraction? Is it a multiplication? I don't quite know what we're doing. And often the numbers are what's kind of triggering their anxiety as well, because if you've got big numbers, if you've got fractions or decimals, that might start getting them into a bit of a panic, because they think, oh, I can't work with those numbers, I don't know what I'm doing. And then it's difficult for them to decipher whether they're adding or subtracting. So we just take all the numbers out. So now we're going to rephrase the question as, Sita has some raisins and she gives some to Ben. So now you can have a conversation with the children saying, well, if you've got something and you're giving some of it away, are you adding or subtracting? And then they'll think, oh, okay, we must be subtracting. And so you have that conversation without any of the numbers, so the children can think, oh, yes, of course, it's an adding one or it's a subtracting question. So then the next strategy really is to just put the numbers back in one at a time. So we're going to add it back in, just one number. Sita has 50 raisins. So now you can have a conversation with the children. Well, if she's got 50 raisins and she's giving some to Ben, how many could she give to Ben? Could she give him 100? Could she give him 1? And just have that discussion with them to help them to conceptualize the problem. So we put the next number back in, and we see that she gives 23 to Ben. So then you can do that part of the calculation. So you can do the 50, subtract the 23. How many has she got left? Well, she's got 27 left. How many can she give to Amy? Have that conversation, and then put in Amy's number as well. So it's really just a way of breaking down the problem and taking away any fear that the children might have about the numbers in that problem. So this is an example of a similar thing. This was from a Key Stage 2 paper in 2018, and this teacher, Jean Knapp, if you Google her and go onto her website, she's got all sorts of wonderful examples. It's well worth having a look at her website. And this was, as a SATs question, and it said the box contains trays of melons. There are 15 melons in a tray. There are 3 trays in a box. The supermarket sells 40 boxes of melons. How many melons does the supermarket sell? So there's lots of information there, lots of things for the children to process. So again, you can just take out the numbers. So there are some melons in a tray, and there are some trays in a box. So how are we going to find out how many there are in the box? Are we adding? Are we multiplying? What is it that we're doing? So you can start having the discussions just like we did before, and then take away one at a time until we've got all the information and we've worked our way through the problem. So numberless word problems, I've used them a lot, certainly with the teachers that I train. They're finding them really useful. The children find it really useful. So I would definitely give them a go, because it can be really helpful. And the other thing that Jean Knapp, this teacher that I was just mentioning before, she does exactly the same thing with graphs and bar charts. And I think this is just genius, because when you look at a bar chart or a graph, or any diagram like that, often it is overloaded with information. You've got the y-axis scale, you've got the x-axis scale, you've got the title, you've got all sorts of things going on. And she just strips all of that away, just gets rid of it all, so the children can focus on the mathematical concept here that's in front of them. And we don't know what this bar chart is about because we've not been given any information, but you could then start having that conversation. What could this be about? What do you notice about the bars as they go across the page? So they're getting bigger and bigger and bigger each time. They're also changing colour. Is that significant? I don't know. We could have a conversation about that. So if these bars are getting bigger each time, what could they represent? So it might be favorite fruits, or it might be heights of children. It could be all sorts of things. So just having those discussions with the children and letting them come up with their ideas helps them to understand the concept here of what this bar chart is meant to be all about. And in a similar way to the word problems, the numberless word problems, we can just add in one bit of information at a time. So now I'm adding in the x-axis information. So now we know that it's about animals, and we've got a mouse, a lion, a human, a dog, and a shark. So what do we think that y-axis is going to be all about? So obviously, if I was in a room with you, you could come up with your own ideas, and I'm sure you have your own ideas sitting at home now of what the y-axis could be. So it could be, I don't know how long they live, their gestational period. It could be all sorts of things. But let's see what it is actually about. So we're going to add in another bit of information. It's number of teeth. So now you can have the conversation with the children. What do you think the scale is going to be on the y-axis? So how many teeth does a human have? So we can maybe think, well, let's count our teeth, and that would be a benchmark for here. So what scale are we going to go up in, ones or tens or hundreds? What's going to happen? So have that discussion with the children, and then we can put in the scale. And then we've got one little bit of information still missing, and that is which animal has the most teeth. So the children can come up with their ideas for that too. And the actual answer is the American alligator. And then we can put the title here, how many teeth do different animals have? So that's a really nice way of looking at bar charts as well. Similar, to the numberless word problems, just take the numbers out. So I'm just checking the time because I know we need to have time for questions. But what I did want to just finish off with and spend a little bit of time talking to you about is this idea of maths anxiety. So whether your child or the learner that you're working with is dyslexic or dyscalculic, maths anxiety is a real problem. It's becoming more and more of a problem, I find. And even if you were the best teacher in the whole world, if you've got a highly anxious child in front of you, it's almost impossible to teach them anything. You have to get them out of that state of anxiety into a place where they're able to learn. And I've had, certainly with the teachers that I work with, a couple of case studies of this that were really fascinating. And sometimes, yes, the maths anxiety is so deeply rooted, it's quite difficult to overcome. But in some cases, it can be such a quick fix if we find out what the problem is, what's causing the anxiety. And there was one example of a boy who was incredibly withdrawn in maths lessons, wouldn't engage, just sat with his head down or his head in his hands, and pretty much refused to do anything. And the teacher got to the bottom of it, and what it was that she had a pot of lolly sticks in her classroom, and all the lolly sticks had the names of each of the children in the class on them, and that was how she decided who she was going to ask the question of. So she would pull a lolly stick out of the pot, and whoever name was on it, that's who she would ask the question. And this little boy was absolutely terrified that she was going to pull his name out and ask him a question and he wouldn't be able to answer it, and he'd be embarrassed. And so and that was the problem. And it was becoming a real problem for him because he was actually getting anxious in the lessons leading up to the maths lesson. So it was even outside of the maths lesson, he was getting anxious. And so the teacher just said to him, right, here's your name on the lolly stick. And she put it in the bin. And she said, I'm never going to ask you. It's not going to happen. So you don't need to worry about it anymore. And within a couple of weeks, he was putting his hand up and volunteering answers. So it was a huge issue for him, but such a simple one to solve. And then there was another example of a boy who, it doesn't always have to be boys, but this was another boy who at playtime was getting into a fight every single playtime, just randomly punching children in the playground. And that meant that he was always taken to the head teacher's office after break for 10-15 minutes to think about what he'd done. And that meant that he missed the mental maths part of the lesson. So his strategy was to get into a fight so he didn't have to do the mental maths. And obviously, once they found that out, they managed to find ways around it. So maths anxiety can be really, really debilitating, but sometimes it can be really easy to fix as well. And back in 1980, there was this definition of maths anxiety, this kind of panic and paralysis. And what's happening with these children is that when they are stressed, when they are in a maths lesson and they can't do it and they're getting really stressed, the body is going into fight or flight mode. And basically, it's telling you to get out of the situation. But you can't, because you're in a lesson. You can't just run away. You can't punch your teacher on the nose. So you can't do the fight or flight. You've got to just stay there. And if this happens repeatedly, it becomes a Pavlovian response. And that means that eventually, whenever you see maths, your brain will just say, nope, I'm just going to shut down. So this is where this kind of paralysis comes in, that you are just shutting off because you know that you're not going to respond in the right way. You can't get out of that stressful situation. And then we've also got mental disorganization that occurs because we know that when children are stressed, it massively compromises their working memory. So often you will get a complete collapse of memory, particularly working memory. And so they can't think straight. And I've done this with teachers in the past where, you know, I'll be doing some training and I might say to the teachers, right, what's 23 times 17? Tell me now. And that's a really stressful thing to say to somebody because their working memory is going to be all over the place thinking, oh, everyone's going to think I can't do maths if I don't get this answer right. Whereas if I said at the beginning of the session, what's 23 times 17? Work it out with your colleagues and tell me at the end of the day, that's not stressful. You can easily do that. So our working memory is very susceptible to stress. And that's obviously what happens when we're anxious. So ways that we can help to reduce anxiety in the classroom, there's quite a few different methods that we can use. One particular one is to use what we would call low threshold, high ceiling tasks. And this means that everybody is doing the same problem. They're kind of easy entry problems, but they can be taken to different levels. And this is really good for the maths anxious child because invariably they have a perception that they're not very good at maths. But if they see that they're doing the same problem as everybody else, and particularly as a child that they perceive to be very good at maths, then they are thinking, oh, I can't be that bad because I'm doing exactly the same problem as everybody else. So it's very good for their self-esteem. And they may well be doing that problem at quite a surface level and not really taking it to any depth, but that's fine. They're having a go, they're doing it, and other children are doing exactly the same thing. Scaffolding can help. So often children just don't know where to start. And the bar model, if you like, is a type of scaffolding. It's giving them a model. It's giving them, you know, a way forward. So getting them started can really help. And then there's this idea of productive struggle. And this is very much from kind of Singapore as well, that the idea is that we want everybody to be struggling a little bit, because that's where they're going to learn. That's where the learning happens, when everybody's struggling a little bit. We don't want the struggle to be too much, because then it's counterproductive. But productive struggle, it's that kind of sweet spot where it's just challenging enough without becoming a threat. Mixed ability grouping is really, really useful, because if children are put in sets, they know if they're in the bottom set, whatever you call it, they know. And also it limits their potential, because if they're in the set with other children who don't understand, they're not going to be exposed to those different ways of thinking, different ideas, different solutions. They're just going to be kind of stuck with their own experiences and not able to make so much progression. But if you have a mixed ability group, then the children are exposed to different ideas and different ways of doing things, and things that they may not have thought about. And even if they don't quite understand the idea, they've been exposed to that higher level of thinking, and that will set a seed in their minds that next time they might think, oh yes, I could have done this, I could have done that. So mixed ability grouping is much, much more effective. And also it helps with the maths anxiety, because the children are working in a group as well. So collaboratively together, they're going to come up with a solution. There's a really good website and newsletter that you can get from a company called Bedtime Maths. And these are lovely. I think it's a brilliant thing. It really is exactly what it says. It's a bedtime story to do with maths. And if you sign up to it, it's free. You just get a maths bedtime story every day emailed to you. They also have books that you can buy and whatnot. But I think it's lovely, because that kind of bedtime, when you're snuggling up with your child and you're reading a story, if there's a little bit of maths in there, it's a safe environment, it's a safe place. You're just about to go off to bed, and what could be better than sleeping and thinking about maths all night? Perfect. So, and they have little questions in there that vary in difficulty, but they're not age related, so you as a parent can choose which question you wanted to ask the child. So that I would really recommend those. Really, really useful resource. And then the other thing to do is to try and help the children to reappraise their anxiety, because a little bit of anxiety is a good thing. It's going to raise our performance because of the adrenaline and that kind of thing. It kind of ups our game if we're a little bit anxious. It's when it becomes too much that we need to think about it. And then obviously make sure that we're focusing more on understanding than memorization. The more visualization, the more concrete manipulatives, the deeper the understanding is going to be, rather than just rote learning and memorizing. And make sure we give children time. I remember a child I was working with when I did one-to-one tutoring, and you know that when you're doing one-to-one tutoring and the parents are paying you for your time to spend with the child, if the child is sat there for 5 minutes in silence trying to work something out, it's really tempting to jump in and help them, because you think, oh gosh, I've got to kind of get through this lesson. And I remember one particular instance, and this child that I'd been working with was really thinking long and hard about this problem, and the time was ticking by, and I was just about to kind of jump in, and he said, no, I'm almost there, I've almost got it. And he wanted to have that experience of getting the answer right, and I just needed to let him have the time to do that, as difficult as it was. So the other thing as well is mindset. There is no such thing as a maths person. You're not born good at maths. So let's get away from that fixed mindset of, oh, well, I'm not a maths person, because everybody can be a maths person, whether you're dyslexic, dyscalculic, whatever. Everybody has the potential to progress in maths and to be able to do maths. Might not be your favorite subject, but you will have the potential to make progress and to understand maths. So we need to also reappraise our response to mistakes and help the children to see that mistakes are actually not a bad thing. That's how we learn. So the more that we can take that on board and not get disheartened when we make mistakes, the better. And we need to make sure that we're developing number sense at an early age. So let's not try and race through the curriculum. Let's just get the basics right to make sure that the foundations are strong and the children are developing their number sense. And then, as I've said throughout the whole of this evening's talk, make sure you're using the equipment, concrete manipulatives, as much as you possibly can, because that's going to develop the visualization and that's going to develop the understanding. And of course, games and trying to make it fun takes away the stress. So a lot of the teachers that I work with, when they're delivering their intervention lessons, a lot of it will be game-based, because that's an immediate kind of relax thing for the children, that they're not thinking, oh, this is a worksheet, I'm not going to be able to do it. It's a game and it's fun and it helps them to relax. So to summarize really what we've looked at this evening, use concrete manipulatives, my number one thing, develop visualization, develop number sense, use the bar modeling to visualize the word problems and use the numberless word problems as well. Make sure you have memory cards or prompt cards to support their recall of facts and terminology, and make sure that your teaching, your experience with maths is very multisensory. Little and often overlearning. 5 minutes a day is better than 1 hour a week. It's much more effective. And try some of those strategies to reduce any maths anxiety that the children may have. So